So moving on swiftly, the next concept we need to get through is gradient. You'll find this on page 204 of the textbook. So before getting into gradient, I just wanted to describe the graph that's on this page. It comes from an equation, y equals 2x plus 2. So I just want to show you guys how we get the graph from the equation. So first off, you can think of an equation as like a recipe. So you put in inputs and you get different outputs. So in this case, we can see that the y-axis, the vertical axis, and x is the horizontal axis. And what this tells us is that the values of y depend on the values of x. So what we're going to do is pick different x's as our inputs and get different y values as our outputs. So starting off, let's use an x input value of -2. So our equation, our recipe, tells us we must do 2 times x plus 2. So if our input is -2, we need to do 2 times -2 plus 2. 2 times -2 is -4, plus 2 is -2. So in other words, for an x input value of -2, we get a y output value of -2. Let's try another value. What if we have x as -1? Our recipe tells us 2 times x plus 2. So we're going to do 2 times -1 plus 2. 2 times -1 is -2, plus 2 is 0. If you're struggling with working these out, just plug them into a calculator to verify. So in other words, for an x input value of -1, we get a y output value of 0. Let's continue for a few more points. So for an x value of 0, we get a y value of 2. For an x value of 1, a y value of 4. And for an x value of 2, a y value of 6. So I'm going to leave out this last point because it goes above the scale of the graph. So now we've got this little table of x values and corresponding y values. And all we need to do is plot these points on the axes. Let's look at the first point. X is -2, y is -2. So we'll look for the x value of -2. X is 2, 1, 0, -1, -2. And then the y value of -2, y is 1, 0, -1, -2. So our point -2 will be there. Next up, for x equals to -1, we have a y value of 0. So this is our x-axis, our x value is -1 over there, and our y value is 0. So our y value is on this line. Next, for 0, as an x value, we have 2 as the output for y. And lastly, if x equals to 1, so 0, 1, y is equal to 4. So this is our y-axis, we count 1, 2, 3, 4. So our point is 1, 4. So now that we've got all these points, we can just join them together. And we see that we get a linear relationship. Now, even though we had dots from this table, it's still a continuous relationship because x doesn't necessarily have to take these whole values. It can take any number in a range. So for example, x could take on the value -2.5 or 1 3/4. So we just used these points to help us see what the shape of the graph should be, and we join the points. So in other words, this graph is a continuous linear relationship. Now moving on to gradient, let's talk about what it means. So another name for gradient is slope. It tells us how steep or flat the graph is. How do we find gradient? The equation for gradient goes like this. Gradient equals rise over run. So that just tells us how much the graph increases its rise for how much it's moved horizontally, its run. If we were to describe it pictorially, the rise between these 2 points is this. Rise, and the run between these 2 points is this. Okay, now if we calculate it, the rise is 1, 2, and the run is 1. So our gradient is 2 over 1, which is 2. So I just happen to pick these 2 points, but we can pick any 2 points we like. So for example, if we picked this point and this point, our rise would be this much. And our run would be this much. So if we now calculate it, gradient equals rise over run. And the value of our rise is 1, 2, 3, 4. And the value of our run is 1, 2. So our gradient is 4 over 2, which is also 2. So notice, even though we used 2 different sets of points, we get the same gradient. So in other words, the slope of this straight line is the same. It's a linear relationship.